All right, guys. Here we go. So here we go, guys. Note 6.5. All of this is stuff that you kind of already know. You just got to make a few connections, and you probably already do know it. You can probably figure it out on your own. So let's just start. So like I said, these questions are questions that you already know. You just got to make some connections here. Given the following point on the unit circle, find the angle to the nearest tenth of a degree, if necessary, of the terminal side through the point -half square root of 3 over 2. All right, on your unit circle, where is -half square root of 3 over 2? In the second quadrant. And what angle is it? Yeah, it's not drawn to scale, but 120 degrees. And there it is. That's it. Now, a word of advice, just in case, if you type, okay, by the way, this is called inverse trig. So let me write this. Cosine with a -1 like that, and then -1/2. That means, what does that mean? I'm going to say theta. Well, okay. That means this. Cosine of what angle equals a -1/2? That's what it means. How do you pronounce this with the cosine to the -1? How do you pronounce it? There's two ways to pronounce it. You can say arc cosine. So say it with me. Arc cosine. Or you can also say inverse cosine. Say inverse cosine. Perfect. So when you talk to your professor and you're like, oh yeah, that's arc cosine of -1/2. That's how you can say it. Or you can say inverse cosine of -1/2. Don't call it cosine to the -1. That's you're technically saying reciprocal there. That's arc cosine or inverse cosine. And all it means is cosine theta. This is what it means. Cosine of what angle is -1/2? And we know that one answer is 120 degrees. There's two answers actually, but the calculator will only give you one. And I think it does give you the 120. So if I type it in here, see how it's in degree mode, make sure your calculator's in degree. The arc cosine, you have to push the second button. See how it's in blue there, cosine -1? So you got to push the blue button and then cosine, so it looks like that. And then -1/2. And I think it will give you the 120. Yeah, it does. It gives you the 120. It doesn't give you the one in quadrant 3. So let me tell you how you would get that. What I advise for you to do is just to always get the reference angle. Remember that the reference angle is always positive, right guys? So the way I would do it, I would just go second arc cosine, and then I would just drop the negative. And just remember, I would just go, oh, okay, that's the reference angle. That's my reference. I know that cosine is -1/2 in quadrant 2 and in quadrant 3. So if I were to tell you what are the angles that make cosine -1/2, you would tell me 180 minus 60, which is 120. And then you would tell me 180 plus 60, which is what? 240, right? So 120 degrees, -1/2 for the cosine, and at 240 degrees, cosine is also -1/2. Don't worry if I said this too much and you're like, I don't get it, Chop. You will. You would also get that answer if you did arc sine square root of 3 over 2. Actually, this is a good example. Actually, you wouldn't get it. So check it out. Don't worry, guys, really fast. If I just type this in the calculator, it will not tell me 120, even though 120 is an answer. So check it out. Before I even do it, let me see what square root of 3 over 2 is in decimal. So square root of 3 divided by 2, and I get that number, 0.866. So check it out. If I type sine of, well, I guess first let's do, okay, I'll just do it already. Sine of 120 degrees, and you do get that number. See how you get that digit per digit? But if I tell the calculator, look at this, arc sine of square root of 3 over 2, I do not, this calculator, and that's, it's a smart calculator, obviously, but look, it does not give me the 120 degrees. Chav, why? Why? The calculator, if you just take away the negative, the calculator will always give you a reference angle if you just turn that coordinate to a positive. So just remember, if you're in quadrant 2, this is my reference angle, 180 minus 60 will give you the 120. Does that make sense? Okay. And don't worry, we're going to talk about more problems. Look, there's more. There's another one right here. So here's how you tackle it. You guys ready? Given the following point on the unit circle, find the angle to the nearest tenth of a degree, if necessary, of the terminal sides between 0 and 360. So here's what I do. And you don't have to be perfect, guys. We just know it's on the unit circle. If you want to draw a grid with a unit circle, that's fine. And here's what you tell yourself. Square root of 7 over 3, square root of 7 over 3, comma, negative square root of 2 over 3. Doesn't have to be perfect. What quadrant is that in? Quadrant 1, 2, 3, or 4? 4. I'm just going to put a point anywhere. It doesn't have to be perfect. Here is that terminal ray. The actual angle that they want is this one. They want that one. I'm going to let the reference angle help me out, theta r. Do you guys see how I wrote theta r? All right. Now don't worry, I'm slowing down. I haven't done anything crazy. Are we okay? So the reference angle is your friend. Remember that the reference angle is never, it's never an enemy, but it's also starts negative. So to get the reference angle, just drop the negative. So look, this is for the x-coordinate, so I'm going to go arc cosine of square root of 7 over 3. This is going to give me my reference angle. So I take my calculator, and I go second arc cosine of square root of 7 over 3. And I push enter, and that's my reference angle. So I get 28.1. So 28.1 degrees. That's your reference angle. If I do the same thing with the sine, notice that I'm dropping the negative. Square root of 2 over 3. I better get the same angle because they better give me the same reference. So check it out. If I go second arc sine, and I already forgot the angle, the coordinate, what was it again? Oh, yeah, but I dropped the negative, right, because I want the reference. Square root of 2 over 3. And look at this. OMG, it should be the same. If it's not the same, there should be red flags because we're talking about the same angle. Does that make sense to you? Okay, Martinez, you okay? Ask me, miss, ask me. Now, this is not the angle I want. That's a reference angle. You are 28.1 degrees away from a full revolution. So how do I get theta? I subtract it, perfect. 360 degrees minus that 28.1. So I take my 360. I go 360 minus this answer. So I'm just going to go minus and scroll up. That's the beauty about these calculators. You can just scroll up to get a perfect number. 331.9 degrees. Theta equals 331.9 degrees. And there it is. How do you feel? Ask, miss.
So why did you do arc cosine and arc sine?
How does that apply to get an angle? Okay, so we got to understand the basic definition. So let me start from scratch. I'm just going to do a simple one, okay? So if I were to tell you cosine of what angle is equal to square root of 3 over 2. So I don't know what that angle is. So how would I get theta by itself? The only way to get theta by itself is to do an inverse. And I know you're like, okay, but that's the question I'm asking. How does it apply, right? All right, so let's go back even further. So don't write this down, just listen. If I were to tell you 5x equals 15, you know that x equals 3, right? But if I were to say, okay, I don't want to see you divide, how do I get that x by itself? Whenever it's an integer, the inverse and reciprocal mean the same thing. So I would go 5 to the negative 1, that cancels that out, and then multiply that by 5 to the negative 1. So this is kind of like an inverse, quote unquote. When it's integers, inverse and reciprocals are the same thing. So this would get you x equals 5 to the negative 1 times 15, and that will give you that answer of 3. Watch. 5 to the negative 1, I push this little button here, times 15, and voila, I get the 3. So now let's do it to the trig. So how do I get the theta by itself, which is just like an x? Well, to get theta by itself, you got to do the inverse to get rid of that cosine in the front. So I go theta equals, and then you go cosine to the negative 1, which is the inverse cosine of what? Of the square root of 3 over 2. And that will get you that 30 degrees. Because the 30 degrees, this is cosine of square root of 3 over 2, right? So check it out. If I type that into the calculator, second arc cosine of square root of 3 over 2, it's going to get me 30 degrees. Boom. Now remember, the calculator is stupid. You and I know that cosine is also square root of 3 over 2 in quadrant 4. Right? In quadrant 4 at 330. So think of that 30 degrees as a reference angle. So from the x-axis, if I go 30 degrees down, that's 330. So watch. If I remember that square root of 3 over 2 stands for 0.866, right? So watch. If I type in cosine of 30, I get that 0.866, which is square root of 3 over 2. And if I type cosine of 330, I get that same number again. But the calculator is stupid. It's not going to give you the 330. So we gotta use our brains a little bit to figure out what quadrant we're in. Did I answer your question like completely? Okay. Yeah, ask away, miss. I'm sure there's other people that have questions too, that have the same question. They just don't want to ask. All right. How do we feel? Okay. Now this one says, okay, so this one, think of it as opposite over adjacent. Well, it is, right? Because it's tangent. It says here, all right, guys, focus. It says, for the problem below, find the reference angle to the nearest tenth and also the two possible quadrants in which theta could lie. Okay, before I even start, remember that tangent is y divided by x. Do you guys remember that? Okay, notice that the output is positive. So y divided by x, and what two quadrants, when I take that ratio of y divided by x, will it be positive? 1 and 3. In quadrant 1, x and y are both positive all the time. And in quadrant 3, x and y are both negative, but negative divided by negative is a positive. So that's what I'm going to write first. Because it says, what two possible quadrants did theta lie? I'm going to write theta could be in quadrant 1 and 3. Always use Roman numerals for quadrants. How do we feel with that? All right, now check it out. You guys already know this. How do I get theta by itself? By taking it starts with letter I, or A, I guess, inverse, or arc, you can say arc, taking the arctan of that. So here we go. Theta equals inverse tan or arctan, it doesn't matter which one you use, of this argument, square root of 35 over 8. Now, because it's positive, this will always give you the reference angle. So it's going to give you the answer in quadrant 1. To get the answer in quadrant 3, take that reference angle and add 180. Does that make sense? Okay, what if you were in quadrant 2? I would take 180 and I would subtract the reference angle. What if you were in quadrant 4? From 360 and subtract the reference angle. Do you guys see like how, and if you're in quadrant 1, it's already the answer. All right, so here we go. I take my calculator, make sure it's in degree mode, and I go second arctan to that 10 to the negative 1, and I already forgot the argument. What was it? Square root of what? Yeah. My short-term memory is really bad when I don't get sleep. I saw the movie Equalizer yesterday, and it was pretty good. Square root of 35 over what? I already forgot it. 8? Yeah, my short-term memory is really bad when I don't get sleep. So there it is, 36.5 degrees. But that's not the only answer it could be. It could also be in quadrant 3. So in quadrant 3, I'm going to put Q3. And I'm going to put an arrow, and I'm going to say that is 180 plus 36.5. And that is what? 216? 216.5 degrees. And there it is. Hallelujah. Amen. Okay. How do we feel? Yeah, the movie Equalizer guy, I don't know, there's something very satisfying about the bad guy getting beat up. Or the bad guy getting what they deserve. I don't know why. It just has so much fun. Sometimes I'm like, what if I were a superhero? But I'm not in any shape to be. Okay. Anyways. All right. Here we go, guys. Here we go. Question 4. So it says, for the problem below, find the reference angle to the nearest tenth and also the two possible quadrants in which theta could lie. Oh, did they want the reference angle on this one? And I just wrote, find the angle. Get the following, find the angle to the nearest tenth. No, that one they wanted the angles. Okay. Here we go. You guys ready? So how do I find the reference angle? I just drop the negative and then just do inverse sine. So theta equals, or I guess I could put theta r because it's a reference angle. Theta r equals inverse sine or arc sine, and I drop the negative, square root of 3 over 6. So I take my calculator and I go second arc sine, and I already forgot what it was. Square root of, yeah, I'm telling you, my memory for short term when I don't get any sleep is really bad. Square root of 3 over 6. 16.8 degrees. That's your reference angle. Now, it wants two locations of where this theta could lie. Where is sine negative? Start thinking about the unit circle. Sine is the value, the y or the x? The y. And what two quadrants is y negative? 3 and 4. So theta could be in And I always spell the whole word, quadrant 3 and 4. That's how you do 3 and 4. That's an IV for, it just doesn't look like an IV. Seriously. There we go. Yeah. How do we feel? Okay, let's go to the next one. This one's kind of an easy one because this one's a perfect coordinate on the unit circle. All right, so it says find all angles, so I need both of them. So I'm going to write theta. I'm not going to do any fancy things. You could do arc cosine, but this one's on the unit circle, so I can give the answer right away. Where is cosine square root of 2 over 2? There's two answers. 1 and 4. What's the first one? 45 degrees. What's the second one? 315. Thank you, miss. Oh, no problem. You're good, miss. Don't worry about it. Okay, no big deal. We're good. Okay. Are we cool, guys? Okay. Yeah, that's it. Yeah, we're what's cooler than ice cold? I don't know. Yeah, Precal. Did I say the song wrong? What's cooler than being cool? Ice cold. I did say the song wrong. Man. Yeah, do you know what I'm talking about? Yeah. Outcast. Wow, I'm impressed you guys know all this. You guys are cultured. Because I didn't think like Generation Zers would know about Outcast, and I thought you guys are all about like Bad Bunny and you know all those other artists. Okay. All right, here we go, guys. Sorry. Find all angles that solve the following equation. Okay, so they don't want my reference angles, they just want the angles. So in your unit circle, where is sine negative square root of 3 over 2? In 3 and 4, what's the angle in quadrant 3? Not 210. 240, that's one of them. And there's another in quadrant 4, 300, sorry. Is that cool? Okay, let's go to the next one. Okay, remember that sine, cosine, tangent are just ratios, guys. So here we go. I'm going to go slow. This is kind of similar to what we did 2 days ago with those notes, with the coordinate. So it says angle theta is in standard position, negative 5, 3. So I go to negative 5, 3, and I put a point. Everyone put a point at negative 5, 3. All right, guys, focus. Draw an angle on the coordinate axis below between 0 and 360. What is the measure of theta to the nearest tenth of a degree? All right, here we go. From the origin, connect a ray or a segment. And draw perpendicular to the x-axis. So just drop it down like so. Drop it like it's hot. Oh, okay. All right, ready? This coordinate or this horizontal displacement is negative 5. And this vertical displacement is 3. I'm going to calculate the hypotenuse, which is like a radius. It's like a radius. The height, relax. I haven't done anything. Yeah, you're going to use Pythagorean theorem. When I calculate the hypotenuse, remember, it's never negative. All right, well, let's just calculate the hypotenuse. It's just a squared plus b squared equals c squared. Sorry, Sabella got me distracted here with the... All right, here we go. Yeah, because you weren't like satisfied, and you're like, "Wow, is he going to do the Pythagorean theorem or not?" Because I don't know what he's talking about. Like, and then I'm like, "Yeah, Pythagorean theorem." Okay, sorry, miss. Sorry, YouTube. I'll stop, miss. I'll stop. It's not a 3-4-5. It's not a 3-4-5 because the leg would have to be the 5 for this to be a 3-4-5. So negative 5 squared plus 3 squared. The calculator is dumb. If you put negative 5 squared just without parentheses, the calculator is going to say negative 25. So if you're putting it in the calculator, make sure you use parentheses. Negative 5 times negative 5 is a positive 25. And 3 times 3 is a positive 9. Cool or not cool? So this is the square root of, and I would leave it like that. Okay, you guys ready? All right. This is the angle I want, but I'm going to find my reference angle. Actually, you know what? We didn't even need to find that square root of 34, but it's fine. Let me tell you why. No, don't worry. We're still going to get the same answer. So I know Cepeda's judging me. She's like, man, child, this is why I'm not learning, because you make everything way harder than it should be. Like, no, but you're thinking it. I can tell. All right, here we go. Here we go, guys. We'll do it the easy way. Don't worry, we're gonna do it the easy way, and then I'll tell you how to verify if you wanted to. So you see that reference angle there, guys? With respect to the reference angle, that 3, is it opposite, adjacent, or hypotenuse? Opposite. What about that -5? Adjacent. Which one, sine, cosine, or tangent, uses opposite and adjacent? So I could have done this. Tangent of the reference angle equals 3/5. Notice that I put reference angle. The reference angle is never negative, so I didn't put the negative in there. Theta r is equal to arctan of 3/5. So I take my calculator and I go second. Oh, don't worry about that, guys. Second arctan of 3/5. And this is my reference angle. And we can round that up to 31 degrees. Yeah, we didn't need the square root of 34, but we would still get the same answer, I bet you right now. All right, check it out. That's a reference angle. That's not my theta. That's not the answer I want. How do I get theta? Subtract it from 180. So 180 minus 31. So 149. I guess we didn't need a calculator for that, but okay. All right. Now, just in case you're wondering, well, Chav, like, why did I get the square root of 34? I didn't even need that. Look, this is just to verify. If I did arc sine of 3 over square root of 34, I better get that 31 degrees. And you do. Check it out. Second arc sine of 3 divided by, with the square root of 34? Square root of 34. And look, you're going to get the same thing digit per digit. Look at that. It's the same thing digit per digit. I'm not fake, so that's why I wanted to show you guys that. If you do arc cosine of 5 over square root of 34, you're going to get the same thing. Check it out. I'm surprised I actually remembered it was 5. Arc cosine 5 divided by square root of 34. Look at that. 3 different ways, same answer over. Yes, ask. Okay, because we're in quadrant 2. No, that's an awesome question. We're in quadrant 2. If I were in quadrant 4, I would have subtracted from 360, but I want this angle right here. And notice I'm only 31 degrees away from 180 degrees. Do we see that, miss? Yeah, no, that's a good question, miss. Keep asking. Keep bringing them. This is a safe space. How do we feel, guys? All right, look. If you understand one question and one question only, it's this one. And if you get it without a calculator, that means you're good and you can get an A in this class. No, look. Yeah, look. So, look. Let's all focus. Let's see. If we get this question without a calculator, that means you understand the basic concepts and you're good and you can get an A. Look what it says. Angles theta is in standard position at 5, 5. So, I'm going to put, well, and go through the point. 5, 5 is the point of the terminal side of theta. So, put a point at 5, 5. Draw the angle of the coordinate axis below between 0 and 360. What is the measure of that angle? And I'm going to connect it. So here's my segment. Here's that angle. Okay. Without your calculator, what does that angle look like to you? Yeah. How'd you get it without even a calculator or anything? The sides are the same. The sides are the same. So it should be making a connection to your 45, 45, 90 triangle. Oh, wait, the 45, 45, 90 triangle, the sides are the same. It should be making a connection to the unit circle. At 45 degrees, the x-coordinate and the y-coordinate are the same. Square root of 2 over 2, comma, square root of 2 over 2. And then you should be like, oh, 5 over 5. If I were to do a triangle here, 5 over 5, with respect to that theta, the opposite over adjacent, 5 divided by 5 is 1. Tan of 45 degrees is 1. So do you see the connection between all the different, do you guys see that connection kind of? If you can see it, and if you know this one by heart, if you know in your heart, okay, sorry, I'm not going to go into poetry or whatever, but do you see how the connection is made? If you can see that, then you can get an A in this class and you should feel happy, like, you know what, I think I got this. If you've been bad at math all your life, but all of a sudden here you're making the connections, you've not been bad at math, it's just that whoever was, and it's no one's fault, maybe it was a pandemic, you just couldn't make the connection, but now you are. Cool or not cool? Okay, so there it is, guys. So theta is 45, because if I were to do, you don't have to, but if you were to do arc tan of 5 over 5, OMG, what do you think the calculator is going to tell you? 45. Look, second arc tan, 5 divided by 5, which I know. Some of you are saying, Chop, just put 1. Look, 5 over 5. You can put 1 if you want. OMG, 45. Cool or not cool? Cool. Okay. All right. So there it is, guys. Now, hold on. Hold your horses. We do have a delta math, but hold on, guys. Hold on. Remember, we have an exam on Monday. All right, guys. Focus. I would work on the unit circle first, on this right here, the circuit training. These are meant, if you were here during the summer, then you know, these are meant to be done as a group. So don't be the person that's by themselves, like, oh, I'm not going to talk to anyone. So in your table, like, talk to your group members, toss ideas around. And you can do it by yourself if you want, but do it as a group. Look, we're going to start it. And then you guys will continue it. Look, number 1. So, and try to do as much as you can without a calculator. It says, that's what it says up there. Evaluate sine of 60 degrees. Well, sine of 60 degrees equals, now, do you have your unit circle with you? Or you don't need it if you can remember, if you have it here. So go to 60 degrees in your unit circle. What's the y value? No, not half. Square root of 3 over 2. That is the answer to the next one. Cool or not cool? So I look for square root of 3 over 2. Do you guys see the next one? What am I going to call that? Number what? Number 2. So then it says evaluate cosine of 180. So I write cosine 180 degrees. Cosine of 180, what was it? Try not to use a calculator, guys. Negative 1. Yeah, use your unit. You can use your unit circle. You can use your notes. And now I look for negative 1. So I call this number what? 3. And it says, well, okay, I'm going to stop right here. But there is one that I wanted you guys to look at. So go to, okay, and I don't know what number that is, but it's this one right here that says answer 2 and arcsecant 2. Yes, sorry. But I've only done 2 questions, so don't worry. You can start from scratch. I'm going to go slow for this. We just learned about this little negative 1. Remember what it's called? Arc or inverse? So you can say arc secant or inverse secant. Remember what this means. This means secant of what angle is a 2. Now don't freak out. If you're like, oh my God, Chav, I don't know what this means. I'm freaking out. Okay, relax. Remember that secant is the reciprocal of cosine. So what that means is cosine of what angle is a half? In quadrant 1, which one's the first one where the cosine of that angle is a half? So that is the answer for when you get to that one. Do you see how to do it? Okay, now be careful. I just want to bring this to your attention. Notice that you have another one here that it says arcsecant is negative square root of 2. But notice on this one, they're telling you where to look. They're telling you to look in quadrant 2. So don't freak out. That's just a Greek letter. That's just a beta. It's just a Greek letter, like X. Like, okay. Okay, say it again. Okay, remember. Okay, I'm gonna do the notes. Don't worry, Smith. Look, secant. I'm not gonna do it for you guys. I'm just gonna get you guys started. Secant of beta is negative square root of 2. What that means was that cosine of beta. Remember, cosine and secant are reciprocals of each other, right? Negative 1 over square root of 2. And I know what you're thinking. Like, Chop, that's not in the unit circle. I've never seen this one before. Guys, that is in the unit circle. You just don't recognize it. If I rationalize it, yeah, some of you are already saying it. If I rationalize it, multiply this by square root of 2 over square root of 2, look what you get. Negative square root of 2 over 2. Now, don't say the answer because we're not in this one yet. Did I go slow enough? Or did I go too fast? I know, okay, I tried to slow down, but remember that secant and cosine are reciprocals of each other. So this is just cosine of beta equals negative square root of 2 over 2. Do not let this freak you out. It's just another variable like theta. Okay? Now, I'm here, guys, so this is why I recommend that you do the circuit here. That way you can turn in the circuit today. And the delta math, gives you a lot of feedback and gives you a lot of... There's a calculator in delta math, too, so you don't need a calculator. You can just do it at home. That's why the delta math, I think, should be the homework part, and this should be done here in class. Ask me. I have it due tonight, but if you think it's overwhelming, let me know, and I'll extend it. It's not a big deal. You know, like I said, I care more about your mental health and you If you like, guys, but okay, don't take advantage. So this is real talk, real quick, guys. I care about you, and I care about your like how you are as a person and your mental health. I really do. If you feel like these deadlines that I'm giving you are like not realistic, you don't have to tell me a story. You don't have to tell me anything. Just say, Chav, I just can't right now, and I'll extend it. But don't take it like don't tell me this every single assignment. Chav, I can't. Like give me another week. Like guys, no, we got to be reasonable. Another day, another 2 days, that's fine. I just can't, I just can't do like a week or whatever because we got to move on. Does that make sense, guys? Are we cool? Now, if you're going through an emergency, of course, yeah, we'll give you time, because life is hard, so yeah, I get it, guys. Are we cool, guys? All right. So work as a group. Do your circuit first, and then you can do your delta if we have time.